All right, section 6. So on this page, we're looking at histograms. So a histogram basically is just a graph that organizes numerical data. Basically, on this one, we have a bar, and this one is going over the servings of fruit. And as you can see on here, we have that we've got 0, 1, 2, 3, 4, 5, 6, 7, 8 fruits a day, and how many. So this side is going to be your frequency. And as you can see on the top of them, I just wrote how many of each one that you have so that you could see the numbers better and I could answer the questions. So now we're just going to answer the questions. So let me get my pen. Let me change the thickness of my pen. It says, how many girls in the study ate 2 fruits per day? And that is 15. How many girls in the study ate more than? So more than means you're 6, 7, and 8. So be careful of your wording. More than is, so for 6 of them, that's 3, 3, 3. So that's a total of 9. Let me change my pen color. How many girls ate 5 or more? So 5 or more would also include the 5 in that. So 5, so that's another 5. Oops, hold on. That's a really bad 9, so let me fix that 9. So then 9 plus 5 will give me 14. And then how many girls were in the study? So if I add up all of my numbers on here, my 15 plus my 11 plus my 15, my 11, my 8, my 5, my 3, my 3, and my 3, that's how many students are in my study. And that will give me a total of 74 students. I also want to know basically what, hold on, I gotta plug in and charge. What proportion, meaning I want a fraction, of girls ate 2 servings. So that's 15 out of 74 students had 2 servings a day. So what proportion of the girls had 2 servings per day, and they want that as a decimal. So as a decimal, you divide 15 divided by 74, and you can do this in your calculator. So to 3 decimal places, that's 0.203. Just type that in your calculator. And then if I want to change that to a percentage, remember you move that over 2 places to the right. So that's going to be 20.3%. Okay, on my next histogram, the bars represent a range of numbers. This time, instead of having the numbers underneath them, they're going to represent them with a range of numbers. And so the endpoints are included on the bar, are included in the bar to the right. This is called the right-hand rule. So what this basically means is if this is 55, that 55 is included in this bar to the right. So this bar right here, this one in here, represents the numbers 55 to 59. This bar in here represents your numbers, let me get the eraser. The eraser might be better. This bar represents 60 to 64. This bar in here represents 65 to 69. So whatever number is at the beginning of the bar, that number goes to the bar to the right. So not to the bar to the left. It doesn't go to both. Whatever that number is, that goes to the right. So if I'm looking for where Mississippi belongs, 75%, 75% is right here. So Mississippi would belong in this bar right here. So Mississippi is in this bar. Utah, 80% is right here. So 80% would belong in the bar to the right. So my Utah would belong in this bar. And then 88% Texas would belong in this bar. Okay, on this page, basically we're giving a table up at the top. And it says the following table shows 50 textbook prices at community college bookstore. And they basically give you the textbook prices of each one. And they want you to basically put a tally mark. So I'm going to try to do this. This table is small. So for example, this 150, the tally mark would go in here. This 88 would go, hold on, I got to get rid of these pens. 88 would go in here. 90 would go in here. 92 would go in here, etc. So to save time on the video, I'm going to pause the video for a minute. I'm going to put all the tally marks in here and I'm going to mark everything on here. I'm going to come back to you in a minute. Okay, so now I'm back after having, basically I just went through each number and I just put a tally mark on its number. So like for example, when I got to 55, I put a tally mark in the 50 to 59 range. When I got to 117, I came down here and put a mark on here, and then I just counted how many I had for the frequency. So when I come over here to my frequency, let me make my pen width a little smaller. If I want to find my proportion, my total, there's 50 of them. I'm just going to basically do 4 out of 50. That's going to give me 0.08. 5 out of 50 is going to give me 0.10. 8 out of 50 is going to give me 0.16. 13 out of 50 is going to give me 0.26. 8 out of 50 is going to give me 0.16. 4 out of 50 gives me 0.08. 2 out of 50 gives me 0.04. 1 out of 50 gives me 0.02. 0 out of 50, that's 0. 1 out of 50, 0.02. 1 out of 50 is 0.02. And then if I add everything up, I should get 1. And there's a total, sorry, there's a screen on here, there's a total of 50. It says, describe in your own words what is meant by frequency. So the frequency is basically the number of books the number of books with prices, not within, with prices in that bin. And a bin, remember, basically was just that in that chart, that bin was like, for example, your 40 to 49 range. So a bin is basically just what they call that range of numbers. It says, what should the relative frequency always add up to? It should always add up to the number 1. Or if you're looking at the percentages, it should always be 100%. So your entire sample is basically 100%. And remember, there might be some error, so it might be it might be a little less, a little, more or less than 100%. So it might be like 98 or 99, depending on your decimals. So when we did 50%, it came out to exactly 1. But if you had, like, say something out of like a 47 or out of a 48, it might not always come out to exactly 1. It might come out to like 99.2, or it might come out to 100.13. So it might be slightly more or slightly less, just depending on what your numbers are. Okay, so your histogram is formed by first dividing your number into bins of equal width. So remember your bins on the other page, then counting how many observations fall into each one. So right now, if you look, they have them split into 40, 50, 60, 70, 80, 90, 100, okay? So it says use your problem in 3 to make a frequency histogram using a bin size of 10. So if I go back and look, they have them split 40 to 49. So first off, I'm going to basically make a title. And the title for that, let me change my pen width. So this is basically my textbook prices. And this over here is my frequency, or your number of books, whichever way you want to do it. Number of books. And then this is my price. This is how much they were. So if I look at, and you'll notice one other thing too, is that we're not necessarily starting at 40. And so they are not starting you at 40 here. So we're not going to make our bar go all the way to the left here. We're going to start our bar a little bit to the right. And so if I go back to the page before, there should be 3 of them. So this is going to go up to, let me try and draw my picture. I'm going to try and draw this the best I can on the screen. Oh, that's a little high. Let me make this a little lower. This has got to go up to about 3. And then from 50 to 60, that one was 4. And then 60 to 70 was 5. Or sorry, not 60 to 70. 60 to 69 was 5. And then 70 to 79 was 8. So that's going to go to here. That's 8. And then 80 to 89 was 13. So that's going to go all the way up to here. I'm drawing this the best I can. 90 to 99 was 4. That's this one. That was 4. And then 100, so let me go back to my chart. 100 to 109. Oh, wait a minute. I got to back up. Let me undo this. Undo. Sorry. 90 to 99 was 8, not 4. Let me get back my pen color. That one was 8. Ooh. And then 100 to 109 was 4. And then 110 to 119 was 2. And then 120 to 129 was 1. We didn't have anything from 130 to 139. And then 140 to 149 was 1. And then 150 to 160 is 1. So that is my histogram. Okay, so number 7 says if we want to use the relative frequency. Okay, so notice this one has a different word attached to it. This says relative frequency instead of just frequency. So relative frequency basically means your decimal. If you go back to your chart a couple pages, you had a frequency column and you had a relative frequency. Remember, your relative frequency was that decimal version. So like those things that were like the 0.08, decimals, the 0.12, etc. So those things. So we're going to put your relative frequencies on your chart. And so those are being the 0.02. So this over here is your proportion of books. Proportion of books. This is your relative frequency. My pen, come on. Frequency. Sorry, I'm trying to do this. Okay, so 0.02, 0.04, 0.06, 0.08. It's not doing a point. 0.10, 0.12. It's not getting this very well. 0.14, 0.6, 0.18, 0.20, 0.22, 0.24, 0.26. So from 40, and the reason I know to do these is because from 40 to 50, this one right here, so from 40 to 49, if I go back on my chart from 40 to 49, I had 3 divided by 50, which was 0.06. So that's how I know that this line went up to the 0.06. And then the next one was 4 was 0.08, and then 0.10. And so that's how I knew to put the numbers on there. So all I did was take the ones off the chart, and this is my price. And this is still my textbook prices. So all I did was basically put the proportions on the side rather than the regular frequencies. Okay, now we're moving on to dot plots. So your graph above is called a dot plot. So you'll kind of recognize that it's the same problem. These are all the textbook prices, except you've got dots above them instead of having a bar. So each dot is going to represent the price of a book. So it says, what does each dot represent? And so basically, each dot represents a textbook. So this time, instead of you having a bar to represent a group of books, each one of these is an individual book. So you can kind of see individually what the prices for your books are. And suppose you have $85 to spend on a textbook. How many textbooks are in your price range? So if I have $85, we're going to assume that this is 80, 81, 82, 83, 84, 85, 86, 87, 88, 89. So here's 80, 81, 82, 83, 84, 85. So here's the 85 cutoff. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 25, 26, 27, 28 textbooks. Oops. 28 textbooks to spend in your price range. So it says, which graph, the dot plot or the histogram, helps you better answer the question in 10? Explain. So if I want to know specifically $85, it's going to be your dot plot. Okay, because it shows you exact prices versus a range of prices. If we have a histogram, all it does is show me how many were in that range. I don't know exactly what's in those. So it says, why do we think that histograms, why do we see more histograms than dot plots in the real world? What do you think is the main purpose for presenting a graph of a data set? So the main purpose is to get a big picture. And so a dot plot shows a lot of detail, but it doesn't show how the prices pile up as clearly as a histogram does. And a histogram is used for large sets of data too. So histograms show large sets of data better. Hold on. Let me try to shrink this in. Ooh, okay. I'm going to shrink this one. I'm going to shrink this in. Ooh, that looks good. Oops, let me get my pen back. So histograms show large sets of data better. They show how data pile up and give a big picture, which we keep talking about, the big picture overall versus individual detailed data. Because if we had like 4,000 textbooks, that would be kind of hard to put all of that on one little dot plot. Whereas if we put it on histogram, you're going to get a better view of your data. Okay, so the extension problems. On number 1, the histogram at the right shows the number of goals scored in 2012 by the first-year women's soccer player in Division III. It says, create a histogram to fit the data. For example, the first bar contains 5 women who scored between 9 and 11 goals. So the first data set could be 9, 9, 10, 10, and 10. Now remember, your answers can vary for this. So one thing to keep in mind is there's multiple answers. So the first bar, there's 5 women in this group. The second one, there's 9. There's 6 in the third one. 6, 1, and 1. So my data set could be 9, 9, 10, 10, 10, like they said for the first bar. And then for the second bar, the one that's the 12, between the 12 and the 14, okay, that could be anything. That could be 12, 12. I just need 9 numbers. 12. I could have 4 12s, and then 1, 2, 3, 4, 5 13s. That's one possibility, as long as there's 9 numbers. That's for the second bar. And then I need 6 of them that are in the 15 to 17 range. So I could have 15, oops, let me close that. So I could have 15. Now I could make these all 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 if I want. I could have them all the same if I want. That's for this bar. And then in the 18 to 20 range, I could make 1 18. Then I could have a 19. I could have a 20, a 20, a 20. 1, 2, 3, 4, 5, 6. That could be this bar. And then in the 21 to 24, or the 21 to 23, that could be 23. And then in the last one, oops, that's this bar. And then in the last one, I could have that be 33. As long as they're within that group, it could be anything. And there's more than one answer to this. It says, suppose that a new player is starting in the division in 2013. She claims that she will score 21 goals. Does this seem likely? So if we're looking at this chart here, if she scores 21 goals, that means she would have to be in this bar. And it seems unlikely because there's only 2 players that are in this bar, between this bar and this one. So basically, I would say no. This seems unlikely because there's only 2 players in the top spots. So it seems unlikely. But this one says another player scores 17 goals. Does this seem likely or unlikely? So 17, 15 to 18, 17 is in here. So this seems, now depending on what you do in here, this seems more likely because it's in the middle part. So I could have all of these be 17. So if these were all 17, that would be 6 here, a 1, and a 1. So this is more likely. So this is more likely to happen. Oops, more. I can't spell today. More likely to happen because it's in the middle half of the group. And it's more likely to be in that middle set of that data. Okay, here is another bar graph, and it's similar to the one that we did way earlier, except this one has, oops, let me get an arrow, except it doesn't have your endpoints at the beginning and the end. It puts a middle one in here, so 55, 65, 75, and 85, which means if this is 55 and this is 65, then that means this is 60 right here, 70, 80. So this is 60, this is 70, this is 80. So you still get the same point. That means for 75, this is Mississippi. 80 would go in here. That's Utah. And Texas is 88. So Utah would also be, Texas would also be in here because this would be 90 down here. And so that would also be in the last bar.